So in this one, I had put B because I thought that it wasn't differentiable because it's a corner. So I didn't think you could find the derivative and know if it was positive or just find the derivative at all. But I think I was wrong. So.
You're partway there, so it's not all wrong, that's for sure. So let's just go down the list real quick. So it says the domain of the derivative. Do you know what they mean by the domain of the derivative?
Isn't the domain when it be like it's open from A to B or closed or any possible values of it?
Let me say that back to you. So let's just talk for a minute. When we're talking about a function, so if we were talking about f, one way to think of f is a list of x and y values. And the graph is a picture of the x, y values. So as I look at the picture, if I were to go to, let's just say this happens to be 1, 2, 3, just for example. If I go to x equal 3, I find a specific point. That point has a y coordinate, perhaps of about -2. And so if I write in my list that when the x coordinate is 3, the y coordinate is -2. Does that make sense?
Yeah.
Cool. If I do that for every point on the graph, once I have the entire list, every x which has a defined y value, that list of x values is the domain of the function.
Okay.
So that's the idea of domain. It says the domain of the derivative. So now we're talking about a different but related function. So these values are found by going point by point and identifying the tangent slope of f. So this is f. I go here and say, oh, that slope, again, I'm just kind of making up the numbers, but let's say that slope turns out to be about, it's about 1. So we'll say the slope is 1. And if I go to 2.9, and I find the tangent slope, the slope's going to still be 1. So I just keep finding slopes along this path.
But the only one you can't find it for is that top one?
Right.
Okay.
So when I get to C, I can't find this value for the slope due to the corner.
But it's only at that point.
Only at that point. So, perfect. So I can say that the domain of f, not f, sorry, the domain of, let's write it down here. So the domain of f prime is, you start at not x equal, you can't find the slope at the very end, but just after the end point you can find a slope, and you can keep finding slope for all these different x coordinates until we get to C, but not including C. So you can't include C. But then after C, you can find the slope again all the way to B. So that would be the domain of f prime, every x coordinate except for C.
Okay.
Therefore, this is a false statement because this is saying every x coordinate including C. If that helped, I don't know.
Yeah, that definitely helps.
And it's just a discussion, Melissa. So anything I say that pops in your head, like, question, clarification, just speak right up. So.
But would 3 be true because, wait, the derivative is positive? How could that be true because it is negative a part of it?
Oh.
So on 3.
So the derivative of f is positive on the open interval.
Oh, because it's increasing from A to C.
Perfect.
Okay.
So f is increasing A to C. So just like you just said, therefore, the 3 dots mean therefore, f prime is positive A to C. And you're correct. If I go from C to B, f prime will be negative.
Okay.
So 3 is a true statement. That makes sense.
Mhm.
Perfect. So you're good with the rest?
Yeah.
Awesome. Then f is continuous. There's no discontinuities along there. So this would also be a true statement. Perfect.
Could we do number 1 on the same page?
Mhm.
I know how to do limits, it's just when